So the problem was to design a descendant family tree for wizards that for each wizard has its name, the house the wizard was placed in, and of course its descendants. And here's my solution. It's a classic sort of arbitrary arity tree structure. Wizard is a compound data made up of 2 strings and a list of other wizards. And what I've done here is to build a simple example, and off to the right here I'm showing you what that example looks like graphically. I've gotten impossibly lucky with this example, as it turns out, and what I mean by impossibly lucky is that later on it's going to be a very useful example for us. You wouldn't normally get so lucky. You might have started with a much simpler example than this, and that would be fine. When we get to the functions, you would have to beef up that example data. So there's my representation for the wizard family tree. I also added I added the data definitions and function structure to the file. And now the first problem is to design a function that consumes a wizard and produces the name of every wizard in the tree that was placed in the same house as their immediate parent. Okay? So if we look at our picture here of what the tree is supposed to look like, we see, for example, that if we call this function with, let's say, the wizard E, we would get back empty because E doesn't even have any children. But if we called it with the wizard G, we would get back a list of the string A because wizard A does have the same house as its parent. They're both in house S. And of course, if we called it with the wizard K, the root of the tree, we would get back a list of strings E, F, and A, because E is in R, which is the same as its parent J, F is in R, which is the same as its parent J, and A is in S, which is the same as its parent G. So we get back E, F, and A. So I want you to design that function, and you may be able to start to see right away that this is a lost context accumulator. If not, that's okay. What I'd like you to do is design this function, take it all the way up to the template stage with an accumulator, and stop there before you jump to the next video. So do the first part of the whole design, take it all the way up through template with accumulator, stop there, and I'll see you on the other side of the break.